Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to the webinar organized by Association of Muslim Scientists, Engineers, and Technology Professionals. Welcome to the webinar organized. And so before I introduce the speaker today, Dr. Karimi, I'd like to say a few words about the organization AMSET that we represent. Again, AMSET stands for Association of Muslim Scientists, Engineers, and Technology Professionals. And as you see on the slide here, that we have a website, www.amsetweb.net. You can find more information about our activities there. So it's registered, the AMSET is registered at in Indiana as a nonprofit organization. We do have a number of social media accounts, including Google groups. You can send any questions, or if you want to become a member of this organization, please send email to this Google group, amset@googlegroups.com. We do have a YouTube channel that you are watching right now, live. We do have a Facebook page as well, as listed here, as you see. And I'm sorry, here. We have a LinkedIn page as well. We have a Twitter account at AMSET20. Also, membership information can also be obtained on our website, amsetweb.net. So my name is Sohail Anwar. This is the current executive committee, and I'm the president of this organization. And we have Dr. Afan Badr as a past president, immediate past president, vice president Dr. Tahir Saif, and secretary is Mr. Rashid Rabbi. I have treasurer Asad Muhammad, and our advisor is Dr. Said Masroor Shah. Again, web page is maintained by Mr. Rashid Rabbi, and career session fair are organized by Mr. Asad Muhammad. Just most of us here are basically professionals, mainly in academic organizations. So, for example, myself, Dr. Badr, and Dr. Saif, all of our professors at universities. Mr. Rashid Rabbi works at federal government in an IT-related field, and also Mr. Muhammad Asad Muhammad is in the IT field as well. So just a couple of things about aims and purpose of AMSET. We provide guidance and assistance to AMSET professionals as well as students in their education careers. So mainly, for example, this particular webinar is aimed at basically, familiarizing our youth and seekers of employment in the field of data science and what opportunities exist and how to prepare for that. So this is part of that. And also we have sessions at ISNA convention, and we have networking opportunities through that process. And also we'd like to disseminate some of the knowledge that relate to both science and also Islam to the audience. That's one of the missions that we have. Also, we'd like to help out, different platforms or organizations in, for example, if you'd like to. If some organization is interested to know what are the boundaries of science and religion, we can contact the right scholar to focus on that. and have them explain to these organizations. We can go to their places or to webinar of this of nature and so on. So those are some of the activities we do. You know, we also try to facilitate science-related activities to improve academic standards in local Islamic schools, facilitate adoption of environmental friendly practices at local masjid and Islamic centers. That's also part of our aims. Ethical issues can arise. I know human evolution, evolutionary theories, AI has many ethical issues that may come up, and we're seeing them actually currently. So how do they, you know, fit in terms of for practicing Muslims, and how to address those situations. 3D printing of organs and tissues, organ transplant, and so on. And those are the things we try to focus on and see how they can actually how to interpret them and how to help our youth and our in general Muslims understand and sort through those issues. These are some of the snapshots from prior Islamic organization sessions that we organized as an organization. And so with that, I think I'll conclude. And this is, if you are interested in being a member, you can go to this website, or you can just send email to msat@googlegroups.com, and we'll be happy to send information about the membership. We'd like, of course, you know, all of us to get involved, and that will help this organization to expand and hopefully help communities that you are in. Thank you. And again, we'll have a Q&A session at the end of this talk, and we can answer your questions about AMSET at that time as well. So at this time, I'll stop sharing this, and I'll ask Dr. Karimi to come on this webinar Zoom session. So thank you, Dr. Ahmad Karimi, and for your time today. And so I'll give the floor to you. I'll just a few words about Dr. Karimi. You know, he is a currently he is an operational data scientist at Oak Ridge National Laboratory in Tennessee. He received his PhD from Case Western Reserve University in computer science. His dissertation was in data science and machine learning to predict degradation and power of photovoltaic systems with convolutional and spatiotemporal graph neural networks. It's hard for me to even pronounce them, but he also received his master's from University of Toledo and BS from Aligarh University. Aligarh Muslim University in Aligarh, India. He also worked as a software programmer and a database designer for 3 years. So with that, thank you again, and I'll give the floor to Dr. Ahmed Karimi. Thank you so much.
Thank you very much, Dr. Thank you for the introduction. Can you please enable sharing for me?
Let's see. So you can't share?
No, when I click on share screen, it says host
Okay.
disabled participant.
Okay, let's see. Yeah, I'm sorry. Let me see. So I think. So to try now, can you try now?
Yeah. Not
no? Yet. Okay.
Do I have to restart or something?
No. I think, let me see. I've done it a little bit. Okay, try now.
Yeah.
Okay. All right. Thank you.
So once again, thank you for the introduction, and thank you for providing me an opportunity at AMSET platform. Assalamu alaikum, everyone. So today, topic of my presentation is introduction to data science and the career opportunities and skill sets that it has and skill sets that are needed. So I go by name Ahmed or by Maruf. And this was about me, but I think Dr. Sohail has already covered this. So, but in addition to that, like if you want to connect with me, it's via LinkedIn or by my email, but my other web presence are at Google Scholar, then Bitbucket, PyPy, and this is my ORNL page. And this is just a side note that these are all my personal slides and I'm not representing ORNL views in this talk. So this is just kind of a disclaimer. Okay, so for in this talk, like there are three main points that I will be discussing about. First, I will be introducing data science. I think many of you would know that, but still, just to bring everybody on the same platform, I think it's important to introduce data science. And then I will talk about the opportunities that we have as a career in data science. And then finally, the skill sets that are needed to avail those opportunities, career opportunities. So obviously the first question that comes to the mind, why data science? Like, why are we discussing it today, or why are we investing our hour in this topic? So according to The Economist, data is the new oil. And it has and obviously one of the reason is the importance that data has, what oil used to enjoy like for over half a century. So that's one thing. But I think there's also one more similarity, that the crude oil is like not that useful unless until it is processed and then made into gasoline or maybe diesel or something. Similarly, raw data is not that useful unless we have a data scientist who does like a data science operations and then make useful inferences from those data. So that's like that makes the data really important. And that's why it is called a new oil. So definition of data science, like as we know, data science is not like a old field, like it's a relatively new area. And also it is such a diverse that it's tough to define data science by just one definition. So there are different ways to define it. I have listed here a few of those, and those are like, so the first point is data science is a process, not an event. So it's not like one task, you have a data, you process it, and then you are done. No, it's a continuous, like you try to work on the data and then come up with new findings and new opportunities that are underlying, which is hidden and not obvious to everyone. So that's one thing. So if you see, all these points are kind of similar, but they are like different ways to present it. And the third one is like, for some of the data scientists, it's called like when you have model or a hypothesis of a problem, and then you try to validate these hypotheses or models. So that process is called data science. For some, data science is just a study of data, just like how biological science is a study of biology, or physical science is a study of physical reactions. So similarly, data is also an entity and it is a physical thing. So a study of data science, data is a data science. So starting with the background, like, is it really a new term, or is it like old or something like that? So as a humankind, like we have been using elementary data science since the time we know, or we have the ability to count and recognize. But those were like very basic things. But with the advent of computers, things have got changed. Like in 1962, a mathematician by name John Tukey performed empirical science using data analysis tools and on data. So that's like one of the first use of, so he didn't use the term data science, right? Because it didn't exist. So he used the term empirical science, but that's the first, one of the earliest findings that we see. However, since then, like especially in the last decades, we have seen a growth of the data in a huge scale, and there are reasons to it. And some of those are like advancement in computer technologies, internet services, smart devices, and so many different kind of sensors like we wear on our wrist, and then others. So for example, here we see, can you see my cursor? Okay, I think so now. So if you see here, like in 1990s, 1 TB of storage would take one big hall of space, whereas these days, like 1 TB would come in a memory, like a small memory device. So that's how the technologies have evolved. And this figure here on the right is by Forbes, and which shows that in 1 minute in a day in 2019, there were around 4.5 million Google search, 4.5 million YouTube videos, and so on. You can see the numbers are like so big, 10,000 Uber requests. So these things have led to a large amount of data, and then these amount of data, when there are like large amount of data, it has led to a new term called big data, which has like, and big data has again like doesn't have a one definition, but I'm not going to go in the detail here, but just wanted to give the term that it exists and it has different meanings. For example, there are different ways to define it. One of the ways is like V's of big data, where V's are related to volume, the amount of the data that is being generated. Velocity means the speed at which it is being generated. So we saw just now, right, 4.5 million Google searches being done, and that was in 2019. So I think it's way more now. Then the variety of data, like different sources, whether it's Wikipedia, so it has text. If it's YouTube, it has videos. And if it's some kind of audio devices, then it will be a signal. So these kinds of things. And then veracity, which is like, so if we have so much of data, like, is it really useful, or are those data corrupted, or they can be used? So that comes, that brings us to the point of veracity, like how good is the data quality? And then the value that it brings, whether it's to the organization or to like the humanity in general, so this is what the V's of the big data are known as. So since there are like so much of data now, obviously then it will lead to some kind of applications. For example, here we have just shown like a couple of figures here just to show like the diversity of applications that it has. So obviously COVID is one of the biggest things that has hit the world these days. But again, the data science has affected it as well. And then we see how there are efforts to map the regions where it has hit worse. Then again, this is the map of the US, which shows the blue and the red regions related, corresponding to Republicans and Democrats, those kinds. This is showing that like no steering. This is a photo of a car which shows like no steering wheels or anything, which is corresponding to autonomous driving and those things. And then Netflix for recommendation systems. So these are some of the few applications. Obviously, there are way many more. And so if we talk about that, then is there any field that is not affected or does not need data science? Obviously not, but then whether it's medicine, physics, communication, commerce, humanities, sports, and last but not the least, engineering. Obviously, all of these would today need data science. So now we come to the point of unicorn data scientists. And by that, I mean, like, unicorn is a mythical creature which has magical powers. So if we relate it to a person, so that person is a rare entity which has like all the knowledge about different stuffs in a data science. That's what called unicorn data scientists. And obviously, it's tough to find somebody who can be labeled as unicorn data scientist, because the field is so diverse that there doesn't exist any one person with all the expertise. But largely, it's the area of computer science, mathematics and statistics, and then the domain science, which makes up the Venn diagram of data science. And the deeper you are in this circle, the more closer to you are being a unicorn. So, but again, even then, this diagram which I got from Quora doesn't include some of the things, or some of the things that are missing here are the way communication, which is an important aspect of data science, because unless until you know how to communicate your results, whether to your higher management or to your clients, it doesn't have the same value. Then obviously ethics and biases that comes with, because data scientists are also humans, so those are the human traits that comes into picture. And visualization is a way to represent the results. So no unicorn data scientist exit per se, but the closer we are to this center, we are better. So now coming on to the major role in the data sciences as science, and what are those? So obviously the first step is the data collection and getting the data. That's the first thing, because we have to know what data is required for a particular solution. And then cleaning it is one of the important tasks. Then visualization and analysis. So visualization is how you are presenting your results. So that's one way. Then there are shiny apps or dashboards, which is like a real time that we see on our computer screens. Modeling and prediction is also a critical part. This is one of the subset of a data science, which is like machine learning and deep learning. So yeah, machine learning per se is in itself is an area itself. Then natural language processing is also a part of machine learning, which deals with text. And then ethics, privacy, and policy. So as we see here, the data science is very diverse, and all of these needs their own engineers or scientists to successfully complete these tasks. So for our in general, a team is needed to complete those tasks. So how do the data scientists or data science team spends their time? Usually, we see that model building and training and deploying is really important. But the time that it takes to prepare the data for model building and deployment is way too high. And we see here 90% of the time is in data loading, because the size of the data is usually so big. Data cleaning, because the data is raw, whether it's from sensors or from different places. So it's tough to make those data into structured format. And if there are missing values or those kinds of things, then we have to impute those values. So yeah. Then there are challenges as well in data science. For example, I think we mentioned these, but again, like here, social impacts that it has from the bias. For example, we see especially in the face recognition systems and those kinds of things. For example, iPhones and those. It usually is biased against certain people because of different factors. And then it also has impact the privacy. And then so these two are the leading challenges, but then there are others as well. So for any organization, data science can help understand their environment better, like how they communicate with their customers or clients. It helps them analyze the existing issues. And I think issues can be anything. Like for example, it could be if it's for let's say for a traffic, it could be rerouting a traffic if there is a traffic congestion or something like that. So that could be the existing issue. Revealing hidden opportunities. So sometimes we even don't know what are the benefits. So using machine learning techniques can help us reveal those opportunities as well. And overall, it adds to the organizational knowledge. So what's the fundamental question that data scientists ask or should know? So data scientists should focus on a specific problem, like what's the problem is. And then they should be able to understand business need and have a clarity in their mind, then only they will be able to, like do the rest of the task there. For example, what data do we need to solve the problem? Unless until we are clear about the problems and it has clarity in our mind, we will not be able to answer this. Because once you start working on these kinds of problems, you are clueless in the beginning. I mean, unless until you are domain expert in those kinds of things. And then once you know, okay, this is the data that you want, but then what are the tools that you would want to capture those data? So those things are also very important. Then other questions are, if you are getting the data from different sources, whether the data will be structured or unstructured, then how will you process those data? Types of analysis that you would do on those data. And then the things, are you going to confirm the assumptions that we had, but we were just thinking, oh, this is what the intuition says, but data science could confirm those intuitions. And then sometimes we will also get new information. Then once the data scientist does all those things happen in the back end. And now is the time to present it to the wider audience. So visualization tools are very important here. The way to communicate, the storytelling is also another important attribute. And then the confidence that you have so that you can recommend some policy change or design changes in the system. So that's also, and these all are part of the communication. So in general, data science is changing the way organization works, the way they use data and approach the world. I think this is just a summary of what we discussed. So now the current state of the data science. We just gave the introduction to it and how it is today. So it's considered the best job in America by Glassdoor. Glassdoor is like a website where related to job search and these things. So since 2016, it has continuously been given the best job in America. And then Harvard Business Review, I think in some year called it the hottest job in America. And as far as the prediction goes, according to global industry analyst, data science platform market will grow by 314 billion in US by 2025. And the job growth rate is 2% in data science areas compared to 8%, which is a national average. And this data is from Labor Statistics Bureau, which is compound growth rate of 38.2%. So this is like some of the statistics, which is giving, again, this statistics is part of a data science. So which is giving us an idea about the scope that this industry has. So as to summarize, like what are the things that industry is looking for, or if we go to the portal, that what are the keywords that industry is looking for, they are looking for data scientists, AI and AI is for artificial intelligence, and ML, I think I didn't mention it, it's for machine learning. So AI and ML engineers. Then again, deep learning is, even though it's a part of ML, but it itself has evolved into a field which is a deep learning, and then it has different shoots in itself. Data engineers, it's like mostly related to data wrangling, data collection, database management systems. So these are the things that comes under data engineers. And then privacy policy and bias mitigation. So this has some roles related to management systems as well. And obviously the experience, the more the experience you have about these systems, the more demand that you will have in the market. Okay, so, and then once you, so what does a data researchers do? Until now, we talked about the data in the industry. Here, I just brought up one slide where it shows, like, what does the data research scientist do? So I think some of the things are similar, but it's mostly related to, like, there are subtle differences. For example, obviously, we will have a measured data analytics that will go computational results. But then there are different ways to present it. Like, usually we would present an article in that, or this article could be a general article, or conferences, or maybe blogs, or these kinds of things. So just wanted to show that. and then how the author approaches, and then how the readers would read it. Like for them, the most important thing is the results that are presented here. So that's one thing. And this pipeline is also a part of the reproducible research. And when I talk about the reproducible research, I think it's related to every science field. Like strength of a scientific evidence is measured by the replication that an independent investigator can do, or the data, which is like is a very generic, like if there is let's say a sensor, so that sensor should has a like if we use that sensor wherever, it should generate the similar data. So that's one. And then replication by analytical methods as well. So if I have developed something and my colleague or my competitor wants to like test, he or she should be able to use the analytical methods that I have and then generate the similar results. So that's like the strength of scientific evidence. Why it's important? So in general, like if a community is working on something, so they can build on a broad policy and regulatory decisions. But the limitation is it's not always possible, and sometimes it's expensive. Like if you are working in an area which is like which is very like running a job for like, let's say 1 week is very expensive on high performance computing, so it's tough to repeat them. So you cannot do that. I'll reproduce that again. So there is a, so what's the alternate to it? Like no reproducibility, that's the extreme end. So reproducible result is something in between there. Replication we cannot do always. Nothing, it's not the best thing that we want to do. So something in between is reproducible, and that we achieve by maintaining data availability as much as we can, sharing the computational methodologies that we have used, documentation of code and data. And I think this is related to software engineering as well. Like the people from the software engineering background would know some of these things. Then standard means, oh, F is missing here. It's a standard means of distribution, like GitHub or other platforms where we use, where we can share our source codes. And then validation. So these are the different attributes of reproducible research. Okay, so that was about like from the research science background. And then now coming to the how to become a data scientist one yourself. So there are different ways to it. Okay, so one of the thing is,
I think the way that I follow it is like master degree or higher degree in computer science, information system, applied mathematics, or statistics. So these are the areas which is like really, the background in these areas would help in making your profile stronger for data science, because these are the things which are needed there. Then, for example, like if somebody is working in a bioinformatics area, then their biology should be strong. So those kinds of domain knowledge. For example, somebody is working in renewable energy, so their electrical engineering, they should have knowledge about the electrical engineering and those kinds of things. So domain knowledge is also important. And then important qualities, that's like in general, analytical skills, communication skills. Again, I mentioned, and I think I focused enough that this is also important aspect. Then also interpersonal skills is part of communication skills. Then logical thinking, math skills, and problem solving. So if you have these skills, you can be a good data scientist, and it's good measures to evaluate yourself. Now coming on to the technical skills that really needed for data science or machine learning. So first thing is a foundation, and I will give so these are just lists, and then I will give exactly what you should know if you want to apply for these kind of positions. So foundation of data science for data science, which is like everybody has to know, because you remember when I talked about the Venn diagram, there was like the more we go deep, the better we are, but then there are some things in the periphery. So everybody should know like foundations. Then data analysis and visualization tools, especially the visualization tool is important. Machine learning, deep learning, recommendation system, and then database. So when I talk about the foundation for data science, things are like Python foundations. For example, you should be, first of all, well aware of the Python, like how, not well aware, like at least you have a, the know-how of like how to run simple programs there in Python. Then some of the, or you should know like these libraries and how to use them. For example, pandas, which is usually used to wrangle tabular data. NumPy is like a computational library, which is for mathematical operations, arrays and matrix handling. Seaborn is for visualization or plotting. And Jupyter is in general a tool which gives a way to write the code as well as describe the code. So that's one thing. Similarly, Python is like Python, we have R, which is also very popular for data scientists. And it has also some of the very common libraries that you should work on. For example, Tidyverse, dplyr, and ggplot2. Visualization and exploratory, you should know like the basics about exploratory data analysis, like what if you have any data, like where do you start from, how do you start exploring the data, so these kinds of things. And then I will tell you the books that you should use to know to like enhance these skills. And then some statistics foundations. The more you know, the better. But basic descriptive statistics, inferential statistics, Bayes theorem, and distributions like binomial, Poisson, or what do you call it? I forgot the other distribution name. Normal distribution, yeah. Then data analysis and visualization. So as I mentioned, like the other after foundation in data science, you should know these things. Like exploratory data analysis come up again, then visualization. There are different methods for visualization. This visualization is different from the one that I was discussing here. It's mostly about like if you have a data set, like how do you and usually the data are like multi-dimensional, right? There could be tens of dimensions, or there could be hundreds and millions of dimensions. So how do you reduce the data so that you can improve the visualization from the eyes or from the observation? So these are the methods that can be used. Then unsupervised learning is also kind of introduction to unsupervised learning. Like you should be introduced to that. And for example, clustering methods like hierarchical clustering, k-means, dbscan, Gaussian mixture. So in the beginning, you don't have to know all these, but the more you know, the better it is. And then for networks, for example, the data, there are data in the tabular form, in the signal form, but then there are some of the data which can be represented by networks or graphs. So the more you are aware about that, the better it is. For machine learning, there are like different, again, like classifications in machine learning, but some of the more important are supervised learning. For example, you should know regression and classification, model evaluation, like you should know cross-validation, bootstrapping, these terminologies you should be aware of. Clustering technique, I think it was covered for visualization point of view, but then again, it comes under machine learning for clustering techniques. Practical data science, and here I mean, I wanted to say like what kind of data set that you get in the real life. Like it could be time series or signal processing. So you should be aware of these terminologies, like what are the different kinds of data. For example, time series, which has a time dependency to it. I think it's obvious by the name. Computer vision, in this field, that the data set which is associated with it are images, videos, and those kinds of things. So videos are actually the collection of images, right? And then natural language processing, where you where the data or the raw data is paragraphs, book, text, papers. So analyzing or extracting information from these kinds of data is called natural language processing. Then graph-based data, which is like sometimes you, for example, if you are analyzing chemical reactions, so usually the graph is the network graph is the best way to represent atoms and molecules, not atoms, like molecules in a model. It could be atoms as well, but I didn't think about that. Then deep learning is again a part of the machine learning, but now it has evolved into its own area. For example, artificial neural networks, which is like a
again, a form of a deep neural network. Then convolution neural networks and graph neural networks. So what are these? You should know about that, and then try to do like sample examples on these, and then which will, so initially all these things would look maybe overwhelming, but the key to this is the more you practice about these things, the better, the easier these things would become to you. And the resources are available in ample on web. Then there are recommendation system, for example, like how Netflix or Amazon or eBay, they recommend us different products or different videos or movies. Even YouTube is a recommendation system. So now coming on to so I discussed about the different aspects of data science, right? What we need to know. And now I'm talking about the different programs that are available online. Other than if you are going for a master program or a PhD program, that's a different story. Then you should really like take the courses which I mentioned, like from those areas of statistics, computer science, mathematics. But if you're already in the industry and then you are looking for switching your profile, then these are the courses that can be helpful. For example, so I haven't like taken these courses, but just from my research, I found these to be like has a very high or positive reviews. That's why I've listed them here. So on Coursera, there's a data science specialization course from Johns Hopkins University. Applied data science with Python specialization from University of Michigan, and this is also on Coursera. Then there is like a statistics and data science MicroMaster course by MIT, and which is on ADX platform. Then there is like self-study kind of a thing. And as I mentioned earlier, like the more you practice, the better it will be, the better you will become. So Kaggle is like a website which provide different data science competitions, and like everybody can take part in those. So if you think you're comfortable enough to like solve those, take part in these projects, it's good to build your to challenge yourself and then improve your skills. So that's the one way to improve yourself. And there are lots of industries which ask for your Kaggle like records if you are applying to them. Like it's not like officially they would ask, but they can bring these kinds of things in the discussion. So it's good to like good tool to improve your skills. And then there are some of the books and which I have used myself, and I found them really useful. Like to start, if somebody is really starting and new to the data science, I would suggest them to start with an Introduction to Statistical Learning book. It's like really applied, and it uses R, which is like kind of the drawback now I feel, because when I started, I didn't think about that. But now I think Python is more in the demand compared to R. But it's still, I think if you can learn one language, it will be easier for you to move to other languages. Still, I will recommend this book. And it gives you a really good foundation for data science fundamentals. And then pattern recognition and machine learning. So this is a little bit of an advanced book, especially for those who know about the foundations and want to improve their knowledge about machine learning. So for them, this is the good book to read. And now coming towards the end of the presentation, now advice to new data science. In addition to the technical skills that we have already discussed and talked about, some of the what do we call it, social skills or something like that, I don't know, which you should have. And again, like this is not like my words per se. So when I was preparing for these slides, I was looking at different presentations and tutorials. So these are the things that I got from there, and I agree with them. That's why I have them here. So you should be curious enough about the things, like just the data in itself should excite you. And if that's the case, I think you tick this box. Argumentative and ability to take positions. So if you have some kind of results which may be against the like preconceived intuitions or ideas, you should have the ability to take the position. No, this is what the data suggests based on the historical data. So we should go by this, whatever the data says. So that the ability to take that position is really important in the industry. Hypothesis or judgmental. So whenever we start data science problems, right? In general, we have some hypothesis, or we build an hypothesis, and then we test our hypothesis, whether hypothesis is fulfilled or not. So that kind of like a judgmental nature is also important. And once you have the results, ability to tell a great story is really important. I think you may not find this really useful in the beginning, but I think it has like really great benefit if you know like how to present your results so that it's like interesting to those who are like new to the data science or who doesn't know much about that, but also to the ones who are expert in that area. So that's one thing. And then the competitive advantage that you might have if you're not from, let's say, the data science background, but let's say you are from the chemistry background, right? Then you have some of the domain expertise in the field of bonds and those kinds of things, chemical bonding, which other researchers may not have. So you already have that kind of a competitive advantage compared to the like a normal data scientist. So again, now coming to the summary of all what I have presented, like again, different websites which are related to jobs, they all list data scientist as the most promising job since 2016. Advantages and pitfalls. So it's in demand. There are lots of positions. It's, yeah, I forgot to mention that it's one of the highly or well compensated area to work in. Diverse and multifaceted, like you have the diverse areas, so you can choose what areas you want to work on. If you're not, for example, if you're not interested in the front end and visualization, you can work in different aspects like model building and machine learning. So these kinds of things. But there are pitfalls as well. Like sometimes, like big data is a buzzword. So we don't have to fall for that. We have to look for like under the hood. Is it really like, do we really know what is big data, what the scientists know? So these kinds of things. So just well-defined area. I forgot why I mentioned this term here. Yeah. Oh, so I think I mentioned this because there is no one area which is like well-defined. So when you are like starting to work in these areas, so maybe you shouldn't constrain yourself to one area. Rather, you should explore different areas. And then sometimes you are dependent on domain information. Again, the things that I mentioned, but especially in bioinformatics and drug discovery, which is a part of data science now, but it is heavily dependent on domain sciences, for example, biologists and pharmacologists and these kinds of things. And confidence in the results. So when you are presenting the results, how accurate is this result? So if you are saying, let's say tomorrow it will be raining, how much confidence you are about the result? Is it 90%? Is it 50%? So these kinds of things you are sure about. You should be sure about that. So overall, that was the end of my presentation. And thank you for your time and listening to me. And I'm open to questions. Yeah. And I also want to thank AMSET for providing me this platform. Yeah.
And so thank you so much, Dr. Ahmad Karimi. Appreciate your taking time and going over the details of your presentation. So so I think for those, if you're listening through YouTube, if you have any questions, you can actually type in the question in the chat box in YouTube, and we should be able to answer that question. So just type in the question in the chat box, and we can. I'll basically bring it up to the our speaker here today, and so I guess. So I I think maybe questions might be coming, but maybe I can ask a question.
Yeah.
So it seems like there is a huge opportunity in terms of because you've shown the job growth next 5 years or so. It's a double digit, not only double digit, it's significantly a higher percentage than any other jobs or so. So obviously, but is there any particular specialty that they have to job seekers have to focus on? I mean, I know data science is a big area.
Yeah.
Are there any particular sub areas that are better than the other areas within data science?
So I think the question wise, it's a very important question, and I can say from my experience, and hopefully I'm not way off the mark. So I would say, first of all, that as the field is maturing, the opportunities are getting like more and more challenging, right? Earlier, even if you had like a little bit of let's say you didn't have any idea about the machine learning, but data analysis, data wrangling, you would make it into like one of the good companies. But now the scenario has changed a little bit. So from that point of view, I would say the recent trends that I'm looking at and what like even my company is looking for is like more of like deep learning and recommendation systems, and then scheduling, which is again like, so I didn't mention one thing which is a little bit advanced, is a reinforcement learning. So which really helps in like scheduling lots of problems. So I think these are the advanced areas which would definitely be like more in demand, more in demand. And then the one more reason for that is again some of the elements. So some of the like let's say fundamental analysis tools, for example, regression and classification, not using deep learning. Again, we can do those steps by deep learning as well, but let's say from using SVM modeling and these kinds of things. So there are so many tools that like us people who are not from the science domain, like data science background, can also go to the online tutorials and learn that, right? So if you want to really be an expert in this area and stand yourself out, you have to know the advanced concept. So that's how I would put it.
Sure. Thank you so much. Okay. So I still haven't seen any questions coming out yet.
Yeah, I would say like if you are like really interested and you cannot ask here, you can reach out to me by email or by LinkedIn. Sure. Yeah, for anything, like if you are a student and you want to take like master's program or something, what courses you want, maybe I can give my opinion. Yeah, absolutely. Yeah, so those kinds of things.
Sure. So I see here Dr. Badr has a question. You mentioned John Tukey, 1962 in statistics. We use Tukey test to compare two means or two groups. Is he the same person who we know as Tukey's test?
Oh, I'm not aware of that part, but I think yes, because he was a mathematician and a statistician. But yeah, I will have to look that up. That's a tough question.
Yeah, sure. Okay.
But yeah, thanks for the question, because it keeps you on your toes.
Right. Absolutely. So
no, I don't know either, Dr. Karim. I don't know either. But we used Tukey's test. No, so that's how I know, because I use the statistics, and you mentioned that back then there was no data science.
Yeah,
so it looks like that he may be the same person. No?
Yeah, it looks like so.
No, because data science uses lots of statistics, and in statistics again you analyze data.
Yeah.
So the only thing is, now you are using a different language, and you're talking about more data than what a statistician in 60s or 70s could have handled. But still, they were able to handle all these things manually. So we have to still give them credit.
Yeah, for sure. Yeah.
Good. So I do have another question from Mr. Qasim Abdullah. And his question is that I'm very new in the area of machine learning. In very simple way, how do we compare ML and statistics?
So there are similarities, there are differences. So first, let's go to the similarities. So when we say ML, I think the statisticians blame that computer scientists have hijacked this term. It's all statistics. So for example, regression, statisticians call them regression, right? But in machine learning, it's we call it as a machine. In computer science, we call it as a machine learning, right? When you have a, let's say, whether tomorrow it will rain or not, right? So what are the variables? Do we see a sunny day? Oh, sorry, whether it will be a sunny or a rainy day. So what are the variables? We have temperature, wind. So let's say, just for simplicity, 2 variables, right? So based on this information, we can, and based on the historical records, we can find out whether tomorrow, or not find out, like we can always predict or estimate whether tomorrow will be a sunny day or a rainy day. So again, we use a classification model in whether it's in a statistic or whether in machine learning, right? So that's a similarity here. But I think the difference lies in like deep learning and those concepts where again, like some of the fundamentals are from statistics, like when we are from mathematics, we can say, where when we talk about the neural networks, so we talk about gradient descent and then convergence. So the idea is the foundation is from the statistics and mathematics, but the way it is being implemented is more of like a computer science nature or machine learning nature. So I think that's the difference. And again, the scale with which, I mean the computational scale with which these models or algorithms are being implemented is also what differentiates the machine learning and statistics. But I think the border or the boundary is not clean here or clear. It overlaps. Yeah. Does that help? Because when I mentioned about the courses that you should take for higher studies, if you want to become like a data scientist, I mentioned these things, right? Computer scientist, mathematics, statistics. So again, see here, if you're from either of these backgrounds, so one of your area will be strong, but then the other areas you should have a like a proficiency, but you may not be expert in those areas. So the boundaries are blurred. Yeah, that's.
So just for further clarification, I guess. So is there like some common theoretical basis between machine learning and statistics, or are there some statistical tools that are used in machine learning, for example?
Statistical tools, like if we talk about, for example, I mentioned regression, right? So when we talk, so the way we so regression is a method, right? So the way that method is actually developed by statistical, like how Dr. Affan was saying earlier. Like they have been using these methods since 1960s and maybe even earlier 50s as well. So those tools, if we say tools in terms of algorithms, those were already developed earlier. But with the advancement in technologies, and now I'm talking about the computer technologies, I mean compute power and those things, and different programming languages, for example, or frameworks, for example, TensorFlow. I don't want to go into that terminologies because we are still in the introduction to data science. So with the advancement in like computational technologies, the machine learning guys have like really taken those things to the next level. That may be the right way to put it up.
Well, thank you so much. And so I think that's very good way that you put it in, and even for me, I think that that's more clear now. So I don't know if anybody else has any other questions. Again, you can type it in the chat box. And thank you, Mr. Qasim Abdullah, for a question. So I don't see anything else. So so I think what we can do, if there are no more questions, we can actually wrap it up. We are also, it's 2 o'clock, so we allocated 1 hour. We can go a little bit more, but if no more questions, we can wrap it up.
Yeah.
So again, thank you, Dr. Ahmed Karimi, and I
can go by just Ahmed. I think it's okay.
Sure. Yeah. And I hope that the audience really has okay. I think there's one more question coming up from Mr. Abdullah. We'll just give it a minute. Yeah, please go ahead, Mr. Abdullah. You can just type it in the chat box. Yeah, so also I just, while he's typing the question, so this YouTube video will be available through AMSET channel. So if somebody just for informational purposes, if someone has missed it, or if you can search for AMSET YouTube channel, and all of our lectures or seminars or webinars are recorded and they're stored in our YouTube channel. So this will be available through the channel as well, in case I were not able to attend it today live. So so the question is that from Mr. Qasim Abdullah again, in your opinion, data analysis can reveal more meaning in ML than in statistics?
Can you please repeat the question?
Yes. So the question is, in your opinion, can data analysis reveal more meaning in machine learning than in the statistics?
I would say it's tough to say like this, differentiate between the two from that point of view. We can talk about the different algorithms that you are using, okay, whether it's statistics or machine learning. If we are talking about regression, classification, or deep neural networks. So if by machine learning, if you mean like artificial neural networks or convolution neural network, these kinds of like deep learning methods, and by statistical learning, you mean regression, then they have different advantages. So first of all, the advantage of regression is it's a simple model. It's easy to understand, but it may not fit like all different kinds of data, right? Whereas machine learning, it can really fit very complex data structure. But since the model is very complex, it's not able to, like, we will not be able to explain how we reach the result, but we will have the final results like maybe much more accurate compared to the regression. So that's the difference. From the explainability point of view, if you want to explain the results,
regression or statistics could be better. But if you are talking about just the final output, for example, you don't know, like, okay, you don't want to know the reaction, like the intermediate steps in chemical reaction. You just want to see, okay, this was the initial output and what was the final output. So from that point of view, like deep learning methods or machine learning would be much more useful. But if you really want to understand like how these transformations happen, then maybe it's tough to understand the complexities in the neural network models. There are ways to do it, which people are trying to do that, like to understand the intermediate steps in ML models. But in a like a general sense, ML models are less explainable compared to statistical models. Like again, when I say statistical model, they're also like ML models. For example, regression is a statistical model, but it can also be said as a ML model as well. I hope it helps.
Great, thank you. I think, yeah, I think it's probably helpful for Mr. Abdullah as well.
I hope so.
Yeah. Okay, all right. Any other questions from the audience? Okay, so Mr. Abdullah says thank you. So
thank you.
Okay, all right. So if no more questions, again, we can wrap this up, and we hope that some of the information presented today was very helpful for the audience, and some who couldn't attend today. For people who didn't attend today or couldn't attend today, can review this webinar later on our channel, as I have mentioned. And with that, I'd like to thank again our speaker, Dr. Ahmed Maruf Karimi, and I wish him all the best in his career that he embarked on about a year ago. And I hope to have him back sometime again for his expert talk next time within this forum.
Thank you. Thank you, everyone.
So much, and I wish everyone a good weekend, and we'll see soon again. Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.